Good morning and good afternoon, everyone. Welcome to this VI Grade Driving Simulator Solution follow-up webinar. This is about open environment. My name is Francesco Ambrogi. I am Service Manager at VI Grade, and I will be presenter today. VI Grade is the only automotive simulation and simulator company to propose one solution for every need that we could summarize in three concepts. First of all, a complete workflow from offline simulation on your workstation down to the driving simulator. It means using the same software, same hardware platform, and in general, the same environment in all the phases of the automotive development process. A unique architecture, we developed our own concept for dynamic driving simulator that is unique in the industry. It is offering, in the case of dynamic simulator, an unparalleled separation of chassis and body behavior. A turnkey and yet open environment. The VI Grade ecosystem contains everything you need from software to hardware, and it is open for third-party software, external models, and can be eventually customized. Today's webinar will be focused on this latter concept, and we will see in detail how the VI Grade environment it is seamless to be integrated in key capabilities with specific needs each customer has and with the tools that he has already in place. Before we go into detail how VI Grade is an open simulation environment, it is important to understand a little bit about the background. At VI Grade, we all share a common passion to accelerate product innovation. You know that traditional methodology for developing new vehicles goes through a typical process of dreaming up concepts, building prototypes, and trying them out. This is in general a very expensive and long process, especially because it may require multiple loops to get into a final product. So we think we have identified better ways to do that through simulation software and simulators. We are trying to allow you to change the order and really drive virtual prototypes early in the process. So within minutes or hours from coming up with concepts, it is possible to feel and experience the effect of the design changes on your product. And all of this is possible way before prototype exists. It is making the vehicle development process faster, easier, and safer. How do we do that? Basically, we do this through a combination of market-leading software, best-in-class driving simulators, and services. And this virtual sign-off solution places us in the gap between testing and simulation. Some companies are pure software providers, others are delivering test machines. We are trying to bring together the best of simulation and hardware to deliver truly transformative solution. So let's talk about open ecosystem. An open environment allows the users to keep using the existing tools on their driving simulators. It means that there is no need to change the development process, and it gives the opportunity of leveraging the existing database of models. So what it is about? VIA-grade open strategy involves several aspects of the simulation process, but mainly it regards vehicle models, graphics, tires, and roads. We will see the details of all of them in a few minutes. The open strategy is not only about compatibility between third-party software and VIA-grade simulators. It is basically a guarantee that the third-party software are integrated with VI Drive Sim, and they work seamlessly with the other components of the VI-grade ecosystem, providing a stable and well-tested interface. The open strategy allows users to link the offline world with the real-time world. So for example, Adam's car interface with VI car real-time. And to use third-party software within the VIA-grade driving simulator environment, having them fully integrated with the VIA-grade technology. So summarizing, we could say that as an open environment, we do deliver an ecosystem to plug in their favorite solution for hardware and software to our customer. We have focused on making sure that we do not deliver just a box of parts to our customers, but really an out-of-the-box turnkey solution that works on day one, but with an open framework that allows them to plug their own solution. This is built upon our VI Drive Sim solution. It's based on real-time simulation using Sim Workbench and real-time database. And we have included a fully documented open API that we use for build up the software components for physics, sensors, scenarios, as well as for motion controllers for our simulators. All of this is made available to third parties so that they can certify their own solution as a plugin to work natively on our simulators, being them static or dynamic, focus on ride handling, ADAS or MVH. With all of these in place, our solution, while unique and complete, can be easily fitting every need. Let's see in a little bit more detail what it is about. On the left end of this slide, you can see the virtual portion of the real-time environment. As mentioned, it is based on Simulation Workbench, and it is the hub of communication with the driving simulator, sending and receiving the signals related to the driver input with the vehicle and all the connected component states. As a portion of this data set, we have a set of modules, the ones in red, that are simulated entries. So vehicle data, control system model, scenario interaction, these are all part of a virtual representation of the system. On the other hand, the blue components represent the entities which are strictly interacting with what is happening on the driving simulator cockpit. So motion cueing controls, graphic rendering, force feedback, biotelemetry, and so on. The interface between those components and the real-time database is working through an open API. And this is done in the same way for the internal tools that VIA-grade is delivering, as well as for third-party solution. So given that any third-party tool must be respecting the communication protocol, the environment can be integrated with any system. So let's see a little bit in more details which are the available possibility for the different modules. The interface between the driving simulator environment and the simulator can be demanded to be defined as a set of input and output, which are representative of the physics of the system. So position, velocities, acceleration of the vehicle body and wheels, tire contact patches location, inputs for the driver, and so on. For this reason, a very transparent interface can be shared and used by any vehicle model, because those quantities are typically computed by any vehicle model available in the simulation. So the options that have been integrated and that are available so far are VI Car Real Time, which is the internal tool for vehicle physics, which is part of the VI Drive Sim environment. But as I said, through the plugin interface, it is possible to connect also external set of vehicle models like Adams Real Time, Modelica and Daimola, CarSim from Mechanical Simulation, CarMaker from IPG, and in general, any user-defined vehicle model. As I said, the only requirement is that any of those will be compliant with the communication protocol between the VI Drive Sim database and the vehicle model itself. You can see that there are also different possibilities in the way that this interface can be set up. It can be through a functional mockup unit, through Simulink, or through direct C++ code, but we spend some more words about it later on. Another aspect that is involved within the usage of the driving simulator is the real-time graphic rendering. So in this case, we are moving on the side of the simulator interface portion of the framework. And it is regarding something which is fundamental component for the driving simulator, because the feedback, the visual feedback that the driver is receiving is strictly depending on that. Also in this case, we are following the same approach. So there is the possibility of connecting several rendering tools, starting from VI GraphSim, which is the option and solution which is provided by VI Grade, which is based on Unity engine, graphic engine. But we do support through a plugin interface also other rendering tools. So we can mention RFactor Pro, AV Simulation Scanner, Virus Virtual Test Drive, and CLab from the Würzburg Institute for Traffic Sciences. Also, new rendering tools will be made available soon. And so also this aspect is covering the possibility of having an open environment for the graphical rendering. Going back a little bit about the vehicle physics, one aspect which is very important and that has been the first customization subsystem available in VI Car Real Time is relating to the tire models. As you know, in the market, there are a lot of tire models available. And for this reason, in VI Grade, we have decided to be able to support the most relevant of them. But again, here we are following the approach of letting the third-party models to plug into the VI Car Real Time simulation environment and VI Drive Sim driving simulator environment directly. So we do support the most popular tire models available in the automotive industry. So Delph Tire, CD Tire is also supported, as well as F Tire. We do support Tame Tire from Michelin, and the Other Ride, Thermoride tire model from Megaride. Also, it is possible to implement a user-defined tire model. This is at any time possibility whenever the tire is compatible with the STI interface. Tire models are, of course, interacting with roads, and ViaGrade can provide services for creating any type of 3D road assets. So a wide variety of high-definition road environments are already available for usage on the driving simulator. So we can provide racetracks, proving grounds, connected automated vehicle sites, highways, urban environments, neighborhoods. So in general, every high quality environment can be made available or eventually implemented using road scanning services. Of course, the road assets is involving in a very important way the graphical representation, but at the same time it is related to the physical representation of the model, of the road model, the road surface. And for this reason, we do provide the VI road solution, which can be seen as an intermediate layer between the tire contact algorithms and the vehicle physics. It can support the internal or third-party formulation, again, through a dedicated plugin. In this case, it is a C API. For what regards the ViaGrade internal road model, it can support multiple contact points and can provide, using the grid mesh approach that will be available in the upcoming release, a very computational efficient performance. It can offer thread-safe parallelization and also some additional important options like the possibility of protecting the IP of the road by licensing and obfuscation. Data can be imported from point clouds, but also from other existing road models like OpenCRG and rFactor Pro. Another aspect related to the realism of the experience on a driving simulator is related to the sound. With VI Sim Sound, it is possible to implement an immersive and accurate sound in any simulator. To do that, it is possible to integrate in the tool the sound libraries that are available and that can be used for modeling the different sound sources from wind to ventilation to engine, transmission and road. And it is also possible to integrate specific custom recordings. So also in this case, the approach is pretty much open to any customization. Going into the simulator cockpit, also in this case, there is a wide possibility of customization. Of course, the cockpit ViaGrade is providing features a variety of systems. First of all, active systems like the steering torque feedback, the active seats and belts, the active brake, but it can be extended with additional features like controllers for ADAS, biotelemetry support, and in general, in-vehicle system support, like UDP and CAN bus integration. So in this case, it is possible to integrate the functionalities provided as built-in by ViaGrade with the existing in-vehicle functionalities. that need to be tested. Going into image display, we have multiple visualization options, basically related to video projectors and video walls. So projectors for screens and domes are supported, as well as video walls by Barco. And we can also support ATC and Vario head-mounted displays. At the same time, it is also possible to have accessory visualization that is included into the standard control room video monitors, and also on the cockpit for side and rear view mirrors for using LCD, or implementing displays for cockpit touch panels. The VI drive sim installation repository is including, as we mentioned before, VI Car Real Time as a default vehicle fix. Car Real Time, in any case, can be replaced by custom modules in different ways. So we have mentioned the different tools that can be connected to drive sim. And the approach is to have a plugin interface that is providing input and output to drive sim equivalent to the ones that VI Car Real Time can produce. There are different possibilities of implementing such plugin, and they offer similar functionalities, but of course a different implementation. The basic approach, say the easiest one, is to connect the external vehicle model through MATLAB Simulink. An interface library is included into the VI Drive Sim installation, and for example, this is the method used for car sim. In this case, it is required the vehicle model to connect the leads required for the different signals to the interface library, and then the model is capable of working with a driving simulator. As an alternative method, it is possible to implement a functional mockup unit, so based on the FMI standard. It will need to create a VI Drive Sim input-output channels within the FMU, and this method is used for connected the simulation environment based on Modelica. The final approach is to use a direct C or C++ interface. This is offering the maximum of the flexibility, but on the other hand is a little bit more complex in terms of implementation because it is requiring specific programming skills. This method is used for car maker, but can be adapted to any vehicle model. In general, all the three of these approaches are following the same principles, and the difference is only related to the methodology used in the implementation. So this is how VI Grade is bridging the gap between testing and simulation, from the vehicle concept to the offline fully simulated environment. We can provide the online environment with the driving simulator, offering the best virtual capabilities by mixing simulated and real components to go down to the vehicle testing and finally to sign off. So by achieving that, VI Grade is breaking the rules of the automotive development process. Going to conclusions, ViaGrade is an open architecture, as you had the chance to see today, which is giving the access of to the most comprehensive automotive simulation tools in the industry. And of course, this is happening from software, hardware, and also from services standpoint. So if you are interested, we invite you to visit our website or our channels on YouTube and LinkedIn. And if you have more specific questions, you can contact myself at my email address, francesco.ambrogi@viagrade.com. We invite you to click on the survey link that will post in the chat window. And now, if there are any questions, we can try to address them. So thank you.
Thanks, Francesco. I'll just bring up another PowerPoint for the questions. Okay. Can you confirm you see the slide?
Yes.
Okay, so first question, can you explain more on active components technology?
Yes, of course, it would require a more extensive explanation, but basically the active components technology is related to the fact that we are trying to provide within the driving simulator the most realistic experience as possible. So we do provide, for example, some components that can, let's say, extend the feeling that, for example, the driver is perceiving from being subject to stationary acceleration. That is typically what it happens on a real car. A driving simulator, being related in general, at least a dynamic simulator, to a limited workspace, is reaching limits that are making not possible to deliver a fully stationary feedback related to lateral acceleration or longitudinal acceleration. In order to overcome this limitation, we have, for example, introduced active seats and active belts technology that are providing a pressure or using the seat belts tension to replicate the force effect on the body of the driver while he is driving the vehicle. At the same time, we do provide active system for the brake in order to be able to give a realistic feedback related to the specific vehicle that is going under testing for what regards the brake feeling, or again for what regards the steering, we are able to replicate the steering feedback, which is coming from a combination of the vehicle dynamics and physics with the assist that is provided within the vector. So those active components are basically complementing the driving simulator in a way that the experience within the cockpit is as much realistic as possible.
Okay, then which type of vehicle components can be customized or replaced in the ViaGrade vehicle physics model?
Yes, this is an interesting question. So in general, as we have tried to explain today, the approach that at ViaGrade we have taken with regard our technology is to keep it as an open environment. So we have been always trying to allow the possibility of interacting with our models, and eventually to extend the functionalities in the case that either specific implementation are existing or more detailed focus is required. So in the vehicle model that ViaGrade is providing in ViaCar Real-Time, this approach is taken basically for all the components, and every vehicle component can be either extended or customized by the user. For example, using the MATLAB Simulink interface, it is possible to override the internal damper or other component forces that are computed by the tool with a specific implementation given by the customer. And this is basically possible for every subset of entities within the vehicle model, being component forces, being tire forces, being road forces. The approach is exactly the same.
Okay. Then are the ViaGrade simulators compatible with external motion queuing controls?
Yes. Again, this is another example of how the ViaGrade technology can be considered as open. So in general, in the VI Drive Sim package, we do provide a motion queuing, which is in fact a result of long research activity. But at the same time, the interface with the physical interface with the driving simulator makes possible to override the usage of the internal motion queuing and to replace it with the motion queuing algorithm that has been developed by the customer. Of course, this is for what regards the control strategy. Then the part related to the actuation of the platform and the dynamic movement of the simulator is still controlled by VI Drive Sim, including all the safeties that are required for this type of machine.
All right. Then is it possible to implement custom tire models using standard formulation, i.e. Passeca, as a starting point?
Yes, if I understand correctly the question, the point is here could be to look for a combination of let's say standard formulation of the tire model with some specific extension of it without having the need of implementing the full tire model from scratch. This is also possible using, for example, one of the customization interfaces that we have been mentioning before, where for what regards the tires, it is possible to separate the different components of the tire forces. And for this reason, it is possible to use a standard formulation like Passeca tires and just override or modify some of the channels that have been implemented. So, for example, you have your own law for the longitudinal force, but you want to keep lateral and aligning torque, lateral force and aligning torque to be compliant to Passeca time model. This is possible because within, for example, the Simulink interface, but in all the other interfaces, it is possible to just pick up the channel related to the lateral force, the longitudinal force, and implement your own functionality.